Hello. We are from the Roosevelt High School Civil Engineering Club in Honolulu, Hawaii. Today, we present our interpretation of the most efficient parking lot design. We started off looking at this design as a whole, then decided to split up into partners and have each pair of people come up with an idea. We then spent the next 2 weeks meeting on a bi-daily basis to critique each pair's sketch, sharing ideas and revising our ideas. After 2 weeks of meeting up, we decided on one final design and started transferring it onto AutoCAD.
With 106 parking stalls and 4 points of accessibility, our model provides the best compromise between efficiency and convenience. We have provided a one-way entrance and a one-way exit for both roads adjacent to the parking lot. This accommodates for the incoming and outgoing traffic between the roads and the lot and minimizes congestion by having access points flow accordingly to vehicle movement. We will start by talking about our placement of parking stalls. To address the irregular outline, we decided to align the central parking stalls with one side of the allotted space. Because the left side had an unorthodox physical structure, we decided to work on the opposite side of the parking lot. We set up parking stalls on the right side of the parking lot, such that the stalls were perpendicular to the side itself. Similarly, we created the aisles slanted the same amount as the right wall. Because the right side was angled at north 9 degrees east and the left side was vertical with the exception of the lower section, there was bound to be a slanted aisle where the lower half was more narrow than the upper half.
We decided to turn this slanted aisle into both a loading zone and a pedestrian zone. There are 3 loading zones adjacent to the building, allowing for loading convenience. The reason it is also a pedestrian zone is to tell drivers that there will be a lot of pedestrians going to and from the building and the parking lot. So then drivers will drive slower and with more care given the circumstances. Because this area flows in one direction, we also had to implement a do not enter sign. As for the remaining stalls, we made them perpendicular to the side they are adjacent to. This design utilizing 90-degree stalls was the most efficient use of allotted space.
Now, we will go into the reasoning for our double one-way driveways. The reason we opted to have a total of 4 openings, 1 entrance and 1 exit for both sides adjacent to the roads, opposed to say an entrance on one side and 1 exit on the other, was in order to optimize circulation and prevent outside conflict. We specifically put the entrance before the exit according to the direction of the traffic. That way, there is an opportunity for a car entering the parking lot to enter more conveniently. Likewise, a car exiting onto the road can exit more conveniently. We also separated the pairs of entrances and exits by placing them farther apart on the same side to help with the aforementioned conveniency, but also to lower any chances of collisions and conflict. If the design were to have the entrance and exit side by side, the way the rest of our design is set up, many of the cars would have to wait for each other in order to get their chance to leave or come in.
Because of the driveways, we had to remove a minute amount of stalls to install hatching for the sake of guiding vehicles entering and exiting the parking lot. We also incorporated 2-way lanes in order to maintain a circular flow throughout the entire parking lot. This was our best representation of how movement throughout the parking lot would best reduce congestion. The 2-way aisles also provide better access to the parking stalls in the middle of the parking lot. By doing so, especially when regarding the aisles within the columns of the parking lots, it allows drivers ample time when searching for a parking space.
For the price breakdown, we obtained our unit prices from official documentation and used measurements to determine the grand total of our design. We need 4,127.7 square yards of asphalt pavement for a cost of $288,941. We need 23 trees for a total cost of $23,000. We need 1,530.14 square feet of landscaping at a cost of $2,295.21. We need 1,352.59 square feet of concrete sidewalks for a cost of $10,820.72. We need 1,647.82 linear feet of concrete curbs for a cost of $29,660.76. We need 37 wheel stops for a cost of $7,400. We need 24 pavement arrows at the cost of $2,400. We need 10 signs and posts for a cost of $4,000. We need 2,848.21 linear feet of pavement striping for a cost of $5,696.42. Overall, our project costs accumulate to a grand total of $378,699.45.
Ultimately, our project provides the best usage of the provided space, maximizes the number of stalls, maintains an adequate flow of traffic, and follows regulations put in play. Our dual-purpose driveways provide commuters with better opportunities to enter from the road or exit onto the road. Our placement of parking stalls best utilize the unorthodox outline of the parking lot. And even though our parking lot does allow an opportunity for drivers to cut ahead in the event of traffic, the two-way aisles play an essential role in keeping a circulation going within the parking lot. Throughout the many weeks our group has spent developing this design, we were able to use this time to develop our own abilities as potential engineers. Time management, creativity, problem solving, work ethic, and teamwork. Our members recognize the aspects of working in the engineering industry that we will use for future projects to come.